Alright, this is part 2 of a lesson about congruence, where in this video we're going to talk about parallel lines that are being cut by a transversal and some other things about angle bisectors, midpoint, isosceles triangles, things of that sort. Alright, but let's start with number 6 here. How can we prove that lines P and Q are parallel? So we're supposed to write these little sort of theorems down. Well, for A, we know that the lines will be parallel because these alternate exterior angles are congruent. See the markings? So you just need to write that down. So there would be your answer to 6A. Since the alternate exterior angles are congruent, the lines are parallel. Similarly, for B, we have congruent alternate interior angles. That will also prove that the lines are parallel. So since the alternate interior angles are congruent, the lines are parallel. Okay? Now, for the consecutive interior angles, they have to be supplementary. Are these supplementary? 123 plus 57? They are supplementary. They add up to 180 degrees. So, we write, since the consecutive interior angles are supplementary, the lines are parallel. Alright, for number 7, we're told that AB is an angle bisector of angle CAD. And we're going to find x and then use that to find the measures of the angles. Well, to be a bisector means to cut something in half, 2 equal parts. So if AB is an angle bisector, then that means that 3x is going to equal 2x plus 25. Okay, so we could solve this for x, of course. If you subtract 2x from both sides, you get x equals 25 right away. Okay, so now we know that x is equal to 25. So, if x is 25, we should be able to find any angles we want. So let's substitute this 25 back in. If I do that, alright, so if I put 25 right here, that means I have 3 times 25. Okay, 3/4 make 75 cents. So this angle is a 75-degree angle. Okay, which of course means that this angle is also a 75-degree angle. Alright, because it's a bisector. These have to be the same. And if they ask us for the whole thing, okay, 75 plus 75 is 150. Okay, so altogether that's going to be 150 degrees. So, the measure of angle CAB. CAB is this top angle that is 75 degrees. What about BAD? BAD is this bottom angle, also 75 degrees. And CAD? CAD is the large angle, that's 150 degrees. Alright, M is the midpoint of AB. We're supposed to make a sketch, so we might as well do that. Okay, so here's AB. And M is supposed to be the midpoint. Okay, so If m is the midpoint, then that means these two sides of the segment are congruent. Now AM is 3x minus 12. And AB is 5x. Okay, AB, 5x, that's the whole thing. Okay, so make a sketch, set up an equation, and solve. Alright, as far as setting up the equation, here's two ways that you can think about it. You can tell that, of course, AB is twice as big as just AM. So you could think of it this way. You would have to double AM, alright? So 2 times 3x minus 12. That's what it would take in order to equal the 5x, alright? You'd have to double this part in order for it to equal the whole thing. Alright, so this is one way that you could write the equation. You could just write that down. Okay. Another way you could think of it is if the left side is 3x minus 12, then this will also be 3x minus 12 since these are congruent. And together, if you add these up, combining like terms, we have 3x plus 3x, well that's 6x. Negative 12 and negative 12 make negative 24. Okay, so the purple side should equal the gray side, alright, because it's the same segment. So 6x minus 24 should equal 5x. And of course, that's the same thing I have here. If I did the distributive property, I'm going to get 6x minus 24. So it's really the same thing. Okay, so we could just solve this for x. Okay, we could subtract 6x from both sides. That's going to give us negative 24 is equal to negative 1x. And then we could just divide both sides by negative 1. So that will give us x is equal to 24. Alright, once you have that, we can find these lengths very easily by substituting the 24 back in. Alright, if I put the 24 back in, then this is going to become 5 times 24. That's 120. Okay, so this is 120. Okay, again, that's the entire length here. Is 120. And if the entire thing is 120, then if I split that into halves by dividing by 2, of course that'll be 60 on each side. So the whole thing is 120. That means this is 60 and this is 60. So AB, that's our 120, and BM, that's just one side. That would be our 60. Okay, that was number 8. Alright, in number 9 we have an isosceles triangle. So understand this, if you have an isosceles triangle, the base angles are congruent. So if these two sides are the same, then that means these two angles will be congruent. Okay, obviously angle A is doing something different. Maybe I'll make it a different color just to emphasize that. A is doing its own thing. But B and C are congruent. So with that in mind, okay, see how we have these expressions for B and C. Alright, but these are congruent, so I should be able to set these equal to each other and solve. So, 8x plus 14 should equal 7x plus 22. Alright, I have x's on both sides, so let's subtract to get those together. That's going to make x plus 14 is equal to 22. Subtracting 14 from both sides. Okay, that's going to give me x equals 8. So I've got x equals 8. Might as well write that down. Now we're supposed to find all of these angles, so really we can just take this 8 and substitute it back into each one of these expressions. Alright, maybe I'll just erase all this. Alright, well, let's start with angle A. Angle A is 3x. Alright, so that makes this 3 times 8, which of course is 24. So that's going to be the measure of angle A is 24 degrees. Alright, now let's move on to B. Again, we know that x is 8. So if I put in 8 right here, then that makes this 7 times 8 plus 22. That's 78. Alright, so that's the measure of angle B is 78 degrees. And of course the measure of angle C is also going to be 78 degrees. I don't need to substitute back in. B and C, base angles are congruent. So if B is 78, then C will also be 78. Okay? Remember, the sum of these three angles should be 180. So that would be a nice way to check our answer. What did I say? 24. Okay, so checks out. Alright, that was number 9. Alright, in number 10, L, M, and N are all midpoints. And when you have midpoint connectors like these, one thing that you find is the midpoint connectors are each going to be parallel to a side of the triangle, and they are their length will be half of the length of the side to which they are parallel. So for example, if ln was 5, then AC would be 10, for example, and these would be parallel to each other. Alright, I'm just making up numbers, but that's the idea. So, LM is here. So that's going to be parallel to BC. Okay. AB is right here. That's going to be parallel to MN. Okay, so that's what's parallel. Okay, what of it? Now, if AC is equal to 14, then LN equals, alright, AC is 14. Where's AC? Alright, AC being 14, that's this whole thing right here. If this is 14, then ln is going to be 7. Alright, because it would have to be half. Okay. Erase, erase. If mn is equal to 8, okay, mn. So mn is right here. If that is equal to 8, then what about AB? Alright, well, AB would have to be double this. So that would have to be 16. Okay, erase, erase. If NC is 3, okay, NC is this little piece right here, so if that's 3, then what's going to be LM? Well, LM is going to also be 3 in that case. Okay? If you need to, you can think of it this way. If NC here is 3, then that means that the whole thing, alright, from B to C would be 6. And of course the LM, the midpoint connector, has to be half the size of the parallel side here. So if this is 6, then this will be 3. Alright? Or you can just do the mental shortcut and know, oh, they're both half. So they're going to be the same. Anyway, 3. Okay, erase, erase, erase. If ln is equal to 5, alright, ln is 5, then what is equal to 10? Well, if that's 5, then this is going to equal 10. And that's AC. Okay. What's going on down here? LM is 3x plus 1. BC is 10x minus 6. Find LM. Okay, we've got some equations to do. Alright, they're talking LM. So LM is right here. And we are being told that that is 3x plus 1. Okay, and then we've got BC, and this is BC over here. And we're being told that this is 10x minus 6. Okay. Now, remember that this longer side here is double the shorter side. So in other words, if I double the 3x plus 1, that should equal the longer side. Alright, double the smaller one should equal the bigger one. Alright, so we can solve this equation. Okay, so of course I'm going to do the distributive property. So that's going to give me 6x plus 2 is equal to this 10x minus 6. Now we need to get these variables together. That should be your very first move. So let's subtract 6x from both sides. I try to keep the variables positive as much as possible. That's the only reason I didn't subtract 10x. But if you felt like subtracting the 10, that would work too. So that's going to give us 2 is equal to 4x minus 6. So then when we add 6 to both sides, we're going to get 8 is equal to 4x. Okay, so then we will divide both sides by 4, and that gives us that x is equal to 2. Alright, so hold that in your mind. So now we know that x is equal to 2. Okay, so x is equal to 2. Now we're supposed to find LM. Okay, but LM is 3x plus 1. But now that we know that x is equal to 2, then that makes this 3 times 2 plus 1. So that's 6 plus 1, which of course is 7. So LM would equal 7. Alright, now number 11. M and N are midpoints, so it's the same situation as before. Alright, so it's really kind of the same problem as before. You'd have to double the smaller one to have it equal the bigger one. So that means if I double the 2x, that should equal the 5x minus 1. So that means 4x is equal to 5x minus 1 if I subtract 5x from both sides. Then I find myself with negative x is equal to negative 1. So then we just divide both sides by negative 1. And that gives us x is equal to positive 1. So x is equal to 1. And if x is equal to 1, that makes this, just 2 times 1, which is 2. So mn is 2. Alright, so that's the end of this page. So again, that'll be a good time to stop this video. End of part 2. We'll pick up with part 3. Let's take a sneak peek what the next video is going to start with. Oh, that's when we're going to get into congruent triangles. Side, angle, side angle, and deciding which one of those postulates will prove the triangles are congruent. So that's what's coming up in part 3 video.